In this video, I'm discussing how the cost to the destination is going to be calculated using the algorithm for Ospf. But before doing anything, what I'm going to ask you is to click on that subscribe button. Also, there is a bell button there. If you click on that and activate that, anytime that I post a new video, you're going to receive it as soon as possible. Give me a thumbs up too. That's going to encourage me to create more of these kind of videos for you. Let's start from router 1 to router 16. Let's say that from router 1 I want to get to loopback interface of router 16, and I want to see how much I need to, what the cost is to get to the destination. That is a better way to say that. So if I go back to router 1 and I'm going to do the show IP route, and I want to see if I see router 16 loopback interface here. As a matter of fact, I see that is 16, 16, 16, 16. So if I want to have more information or in detail information, so what I'm going to do is to type show IP route 16, 16, 16, 16. So it says that because that's a loopback interface, although I have it defined 24 bits when importing the network, but here what I see is a 32 bits. And of course I can change it if I want to see that as 24 bit. What I need to do is to change the network type here. So if I just type show IP Ospf interface loopback 0, you can see that it says the loopback interface has a network type of loopback. But if I change it to this interface, for example, loopback 0, I can say IP Ospf network. And you see that there are different options. Anything other than loopback is going to change the equation for me, and the 24-bit mask is going to be, sent to Ospf database. So let's say that, for example, I'm just typing broadcast, right, and hit enter. That's going to. It says, of course, this is not a good one for this. So let's go for point to point. That's a better option, I guess. So when I did this, if I go back to router 1. And check this, it says 16, 16, 16, 16 is no longer in my routing table, but 16, 16, 16, 0 / 24 is there. So if you want to change the behavior, all you need to do is to change the loopback interface type, the Ospf network type. So I'm going to show IP Ospf interface loopback 0 one more time. Course interface, and now it says that the loopback interface has a network type of point to point. You see that right here, and the information is of course a little different. So this is one way. Most of the time, of course, when we are going to talk about MPLS, you will see that this 32-bit is going to be more important for us. So it doesn't really matter what we did here, but what we are doing here is to check to see the cost to the destination. As a matter of fact, this is very much important for me. Here it says the metric is 51 and the type is Intra-area. So on here, router 1 sees a metric of 51. So let's see how many hops do we have to get to the destination. One simple way to do that is to trace it. So I just go and trace 16, 16, 16, 16, and it says that I have 5 hops to the destination. You see that? So each hop would be something like a 10 for the destination, and because loopback interface is a network connected to router 16, although it is connected internally, but as a matter of fact it's a network connected to that, there is a cost of 1 to get to that as well. So why do I say 5 by 10s? So that gets us to here. That is the cost of 50. Why 10s? Why not more than that? The interface type that we have in this network, all of them of course are Ethernet interfaces, right? And Ospf has a very interesting way to calculate the cost to the destination. And it says that based on the bandwidth, I'm going to give it a cost. And this is a little different from the normal cost that you calculate for, let's say, for spanning tree or something like that. I am just assigning this as this protocol. So I said that for the length that it is 10 megabit per second, the cost is going to be 10. So if I have 5 hops to the destination, this is going to be summed up. So we have 5 tens. That's going to give us a 50. Also, the loopback interface has a cost of 1 to get to the destination. That's going to be added, so we see 51 in there. Now you might say, okay, what if I have faster links? What are the costs for that? For 100 megabits per second, the cost is going to be 1. For 1 gigabit per second, the cost is 1. 10 gigabit per second cost is 1. Why? Because the reference bandwidth is 100 megabit per second by default. Now, let's say that our networks these days are very fast, and we do not really think of 100 megabit per second as a fast link. We say that 10 gigabit per second is a fast link. And most of the routers and switches that we have these days support 10 gigabit per second very nicely. So why shouldn't I say that the reference bandwidth is 10 gigabit per second instead of 100 megabit per second? How can I do that? First of all, you need to know that this is important to enable this on all routers in your network, because each router calculates on its own. It doesn't calculate based on others' calculations. So all of them should agree on one standard, although this is not mandatory. And the command is so simple. So all you need to do is to go to Ospf process, so rather Ospf1, and there is a command that says Autocast reference bandwidth. And like I said, the default is 100 megabit per second. And it says that everything that you are going to type here is going to be based on megabit per second. So 100 megabit per second is like that. 1 gigabit per second is going to be represented as 1000. And if I want to say that 10 gigabit per second is the thing that I am going to choose as the reference, that's going to be 10,000 megabit per second. I hit enter, and it says that please ensure reference bandwidth is consistent across all routers. Like I said, that is because of the calculation. Everything is going to be kind of homogeneous across the routers. So I'm going to do this. I'm going to open a notepad, and then I'm going to type the commands here. So that's going to be enable. Then let me zoom in a little bit so that you can see it much better. Configuration terminal. I go to router Ospf process, and I'm going to type Autocast reference bandwidth 10,000, and I'm going to end and save everything. Then everything is going to be done correctly. So I'm going to copy that, go to router 2, router 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Switches do not support Ospf for now, of course, so I'm not going to do that on them. And let's go back to router 1 now. What I'm going to do again is to show IP route. Of course, I need to wait a little bit because routers are going to refresh their calculations. It will take some time, but let's go and see 16, 16, 16, 0 and hit enter. And this time it says that the metric is 5001. Why 5001? Because now the metric is 100 times more than before. So each 1 gigabit per second link is going to be 1. 100 megabit per second is going to be 10. 10 megabit per second is going to be 100. Right? Or, no, sorry. 10 gigabit per second was going to be 1. 1 gigabit per second is going to be 10. 100 megabit per second is going to be 100. And 10 megabit per second is going to be 1000. And there is a loopback hop, of course, that's going to be just 1. So we have 5 1000s. That's going to be 5000. And there is a 1 there, which is going to give me 5001. And this is what I see here. Right, so this is the way that we calculate metric from one side to another side. So you might argue that, okay, what about the areas? What do I see here is my cost to the ABR. I do not really see the cost from ABR to other ABRs or to other areas. So what should I do? So Ospf calculates its own areas cost to get to the ABR. So router 1 says, I don't know anything about other areas, but all I want to know is how to get to router 7. What is the cost to get to router 7? So I get to router 7 and the cost is going to be, let's say, 1, 2, 3, 4, something like that, right? And with 4 hops, I get to router 7. And from router 7 to the destination, I have no information. All I have is just a summary information. And that is what router 7 reports to me. So router 7 says that to get to that destination, the cost is going to be that. I'm going to add that cost to the cost that I have, and that's going to be what I have. So let me see this in a better way. So I'm going to show Ospf database, and what I'm going to do is to check one of the summaries. Why summary? Because this is LSA type 3. Why type 3? Because this is what ABR is given to me from other areas. So what is the summary that I have here? Let's just hit enter. I'm going to look for 16, 16, 16, 16, just by pressing you know, this space and get to the end. And I'm now going to look for 16, 16, 16 something. So where are you, 16s? That's gonna be somewhere around here. Looking for so much information. I should have typed it. Here it is. Now it says that the router that is advertising is of course router 7. And now it says that the metric to get to the destination is 1001. I don't know how it has calculated that. I don't care about that. All I need is the metric to get to that destination. I am going to add the metric that I need to get to this ABR. That's all I need to do for the calculation. Okay, so let's do something else. Now that we know how to calculate the metric to other areas, what about calculate the metric to areas which are not Ospf? Let's say that, for example, on area 300, what I'm going to do is to enable rip here, right? I'm going to have some rip routes on router 15, router 14, and router 13. So let's go to them. Let's go to router 13. I'm going to do this, show IP interface brief. I'm going to see what kind of interfaces I have. So I'm going to enable network 110 and network 13, and then I'm going to, not 13 as a matter of fact, I'm going to have some more loopback interfaces. Let's go here, and I'm going to type interface loopback 130, right? An IP address is going to be 130, 130, 130, 130. This is the network which I'm going to have. Right? Okay, let's enable rip. Then I'm going to have redistribution, of course. No auto summary. Version is going to be 2, and then the network is going to be 110, and network is going to be 130. Of course, 130 is going to be class B, so I need to have 2 octets here. Okay, no passive interface. Let's go to router 14 and 15 and enable rip on them as well. So I'm going to go to here, show IP interface brief. I'm going to have a loopback interface. So what was the loopback interface? What did I do on 13? I just changed the, oh, so 130, okay. Loopback 140. I'm going to have IP address of 140, 140, 140, 140. That is the mask. Router rip, of course. The network is going to be 110. The network is going to be 140, 140. And that is the configuration that I have here. And then save everything. Let's go and do the same thing on router 15. So IP interface brief. Going to have interface loopback 150. IP address is going to be that. Okay, router rip. No auto summary. I didn't do that, right? On the other side, version 2. So that's going to be network 110, network 150, 150, and save. So let's go back to router 4 and change the version here. Router rip, version 2, no auto summary. Okay, so let's go back to router 13. That is going to be my first rip router, and also I need to enable it on router 11. That's going to be my ASPR later. Okay, so let's go to router 11 and do the same thing. Show IP interface brief. I'm going to go to configuration mode and I'm going to have router rip version 2, no auto summary, and now I'm going to have network 110 enabled. So what do I have here? Show IP route, and I'm going to have only rip routes here. I see 130, 140, and 150, and I see that the hops to get to destinations are 1, 2, and 2. That is how metric is calculated for rip. So what I'm going to do here is to redistribute this into Ospf. So router 11 is going to be kind of an ASPR for us. So I'm going to, let's say that redistribute Ospf 1, and then I have a metric of just 1. Every route from Ospf is going to be imported into RIP database. They are not going to be used. Why? Because this is RIP and it has much higher distance than Ospf. Ospf has 110, this has 120, so they are not going to be used. I'm not worried about the loop here. And I'm going to assign metric of 1. That's okay. Let's go to router Ospf 1, and I'm going to redistribute rip here, and I'm going to redistribute all the subnets. Now I'm going to hit enter and then go back to router 0. What I'm going to do here is to show IP route to 130, 130, 130, 130. It says that I know about the destination 130, 130, 130, 0/24, and the metric is 20. Router 1 says from me to the destination the metric is 20. That is a little weird, right? So if I just check here, just from router 1 to router 7 the metric was something like 5,000, and from router 7 to router 13 I have many more hops. So why is the metric so low here? Now if I check here, it says that this is a type external, and the type is type 2, right? In type 2, what I get is just what the ASPR has advertised. That's all. Default is type 2, right? If I go back to router 1 and check the redistribution one more time, I'm going to add something to this command. And if I press a question mark here, it says that I have something which is called metric type. For Ospf and IS2IS exterior, metric type is redistributed. Both of them, of course, support metric types. So what is metric type here? I can assign a metric. I'm not going to assign a metric because I'm going to give it, give the role to this. And here it says we can have metric type 1, we can have metric type 2. We didn't type anything, so all we got was the default value that was metric type 2, right? So I'm going to go back to router 11 and I'm going to say metric type 1 this time and hit enter. Now this is going to withdraw the route, and again it's going to advertise the route with this new metric type. And now if I check this, it says that the metric is 7020 to get to the destination, and the type is external type 1. So when you are advertising an ASPR, an area, an autonomous system into Ospf, you have two options. The metric type 2 is going to be the default, and it's going to assign a metric of 20 by default. That is 20, right? And it says that everything that I'm advertising is going to be 20. Any part of the network is going to receive that. They are not going to change it. But if you change it to type 1, then the actual metric to get to the destination is going to be added, and that is going to calculate the metric to the destination itself. That they are going to be combined, and they are going to give you this here. So one more time, what I'm going to do is to show IP Ospf database and hit enter. And if I go down here, you see that I have external links here, type 5 external links, and one of them of course is the one that we are looking for. So if I just say that what type of data I'm talking about external, and I'm going to say 130, 130, 130, 0 and hit enter. It will give me full information about that. It will say that the metric type is 1, comparable directly to link state metric, and the metric is going to be 20. Of course it says 20, but we are going to calculate the path to get to router 11, so that's going to be 5,000 to router 7, and from here to router 9 6,000, and from here to router 11 7,000, and it advertises it with 20, so I get 7,020 to get to the destination. So this is how the metric is going to be calculated in Ospf. We saw the Autocast reference bandwidth command and the effect of that, and also, like I said, you can change these values as you wish, but if you want to do it, you need to do it on all routers. Also, now you have an insight on how the metric to the destination is going to be calculated by summing up the values and type of the redistribution, if there is a redistribution in your network, and understand everything.